English with Astronomy. Episode 1.
Our first episode is called Who Invented Astronomy? Astronomy is one of the oldest sciences and perhaps the most fascinating. Since ancient times, watching the sky has helped people make calendars and understand the change of seasons. Astronomical knowledge was essential in ancient Egypt, Babylonia, India, and China. It supported farming, hunting, fishing, herding, and long journeys across deserts and seas. Maps already existed, but their accuracy and availability were limited. The compass, invented in ancient China, spread widely beyond the region only centuries later. The sky, however, was often clear, and the stars guided travelers reliably. Their apparent motion across the heavens is regular and predictable, so they served as steady landmarks. The start of farm work often matched the appearance of certain stars in the sky. It was time to plow, sow, or harvest. Grand structures such as ziggurats and stone-built observatories were not only temples, but also instruments for observing. In Egypt, the rising of Sirius signaled the flooding of the Nile. Priests kept calendars of festivals and planting by the positions of constellations. In many cultures, from the Maya in Mesoamerica to the ancient Greeks in the Mediterranean, the sky was nature's common language for telling time. Astronomical observations made it possible to keep track of time, day and night, the phases of the moon, and the seasons. In this way, the first calendars appeared thousands of years ago. Step by step, observations grew more precise, leading to sundials and water clocks, and later to more complex mechanisms that aligned lunar and solar cycles. The better people understood the motions of celestial bodies, the more confidently they planned their lives, when to go to sea, prepare for cold weather, or begin the harvest. Later, a larger question was added to practical needs. How is the universe arranged? The idea that the Earth is not the center of the universe required courage. The work of Copernicus, the observations of Galileo, and Kepler's laws revealed order in the motions of the planets, and Newton explained it with the universal law of gravitation. With the invention of telescopes, people extended their sight. They saw mountains on the moons of Jupiter, and the rings of Saturn. Thus, astronomy turned from a set of signs into a rigorous science based on measurements, calculations, and tests. In modern times, other eyes joined optics, spectroscopy, radio telescopes, and space observatories. We learned to determine the chemical composition of stars from their spectra, to measure distances to nebulae, to watch the birth and death of stars, to search for exoplanets, and to look for traces of water on other worlds. The space age opened the way for probes and satellites that observe from above the clouds and most of the atmosphere, where there is less distortion and absorption. Thanks to this, astronomy remains not only ancient, but also one of the most modern sciences. Its practical value has not disappeared either. Navigation and wayfinding, precise timekeeping and positioning systems, space weather forecasts, understanding how the sun and orbital cycles influence climate, and ideas about the origin of chemical elements. All of this grew from astronomical roots. By observing the sky, we better understand our home and its place among countless worlds. The French astronomer Camille Flammarion wrote that astronomy is the basis of general education. Without it, a person would not understand their place in the universe. It connects past and future, practice and curiosity, and every look at the night sky reminds us how vast the world is and how much there is still to discover.
Well, the first story from my star book has officially launched into space.
Wow, what a powerful start. I was listening, barely breathing.
Your turn, host. What questions have you prepared for our listeners?
Here we go. After Susie's story, please answer these. First, which civilizations mentioned relied on astronomy? Second, Which recurring celestial events did people use to mark farming seasons, and what Egyptian example was given? Third, what practical benefits do we get from astronomy today? Finally, how does Camille Flammarion describe astronomy's importance for education? And now, a short recap.
Excellent, Jimmy. That kind of overview helps everyone lock in what they've heard.
All right, let's go. Astronomy is ancient and practical. By watching the sky, early peoples built calendars, timed the seasons, and navigated long journeys. Cultures from Egypt to China and the Maya used stellar risings like Sirius and the Nile floods, and even built temples as observing instruments. As observations grew precise, people tracked days, lunar phases, and seasons, inventing sundials, water clocks, and calendars that aligned the moon and sun. Curiosity then widened the aim. Copernicus, Galileo, and Kepler revealed a lawful heliocentric cosmos, and Newton explained it with universal gravitation. Telescopes opened new sights, lunar mountains, Jupiter's moons, Saturn's rings, turning sky lore into measured science. Modern tools, spectroscopy, radio astronomy, and space telescopes let us read star chemistry, gauge cosmic distances, watch stellar life cycles, and find exoplanets. The space age moved observatories above most of the atmosphere, sharpening our view beyond clouds and distortion. Astronomy still serves daily life, navigation, precise time and positioning, space weather forecasting, climate insights, and understanding the origin of elements. As Flammarion said, it grounds general education by showing our place in the universe and reminding us how much remains to discover.
Thank you, Jimmy. We've just flown through millennia again.
On that note, let's wrap up the first episode of today's series and move on.
Next, without a pause and almost weightless, comes the second episode. I'll tell you about one of the most famous thinkers of ancient Greece, how he pictured the universe, and why he believed Earth is a sphere.
Switching to the next chapter.